Good morning, good afternoon, or good evening, depending on where you are right now. Let me start off by thanking you all for joining us today. It is my absolute pleasure to be continuing this series of webinars that ProSoft has been conducting to share some of the issues that we've seen in the field and how we solved them. Today's topic is what I can best describe as industry critical. We will be looking at modernization, reasons for it, its importance from a technical point of view, and the migration process from old to new. This is part 2 of a 2-part run. A video recording of part 1 is available on demand on YouTube. Let's start with an outline of this presentation. I'll start off by defining modernization from my point of view. We will make out the reasons for modernization by examining some real-world scenarios. After that, we'll discuss the options that you have available to you when modernizing by looking at the actual migration process. We'll look at some of the solution examples before concluding with a question and answer session. As I'm going along, if you have a question, please type it in the chat window and we'll discuss it at the end of the presentation. But before we go into that, let me quickly introduce myself. My name is Simon Kembo. I'm a technical support engineer for ProSoft Technology. I've worked for ProSoft for almost 5 years dealing with both wired and wireless solutions. So what is modernization? Industrial equipment will always be required to evolve with time. This is in order to meet the growing need for efficiency and reliability from a plant point of view. Modernization is the realization of that evolution, the change from old to new. This process can be extensive, changing the entire system into a new one, or it can be pretty small, simply upgrading your firmware for your Rockwell controller, for example. But for this presentation, we'll be discussing the large-scale effort of changing processes, controllers, and components. We'll talk of removing legacy equipment and replacing it with up-to-date equipment. Legacy is in quotes here because what makes a product legacy is defined by the manufacturer. As the saying goes, beauty is in the eye of the beholder. So it is the manufacturer, ProSoft or Rockwell, who will say that one of their products is legacy, usually because it is too old and too costly for them to keep manufacturing it or supplying it, or in very rare cases, supporting it. There is an estimated over $65 billion worth of legacy equipment installed and running. That's 65 billion with a B. That is $65 billion of equipment that will be difficult and expensive to replace when it eventually dies. I mean, nothing lasts forever, except for the characters of a Twilight movie, let alone the difficulty of finding people who are qualified and able to replace those devices. So from that point of view, the reasons for modernization become evident. First and foremost, you want to increase the productivity of your system. If you can perform a task more efficiently, you can generate more profit. And at the end of the day, it all comes down to dollars and cents. Contrary to the popular lyric, the more money you come across, the less problems you see. You also want to keep up with the times. Each product iteration is meant to make the product better than it was before. You want to leverage on that improvement and use it to your benefit. Then you have the issue of availability. When manufacturers deem a product as legacy, it is in their best interest to stop manufacturing said product at a high cost. That means replacement parts will be much harder to get hold of, and say you have a connection. The laws of supply and demand will still apply. So you should expect to pay more. And this leads to the conclusion that not modernizing is just bad business. Now, to get the point of productivity across, let's look at a numbers example. Say you have a remote I/O network connecting a legacy PLC to legacy I/O at a bottling factory. The controller is responsible for bottle capping. Say you have a bottle spacing of 2 meters and the average real latency of 500 milliseconds. The fastest your belt can travel would be proportional to the rate you can tell the I/O to start the belt, plus, because communication to different I/O blocks is not instantaneous, the time it would take you to tell the I/O to cap the bottle. That comes up to 2 meters per second. And if your bottle spacing is 2 meters, you can only cap one bottle at a time, or one bottle every second. Now let's assume that the revenue from this process is $2.35 per bottle. It means that system can make $2.35 every second in revenue, which are not bad numbers. But John Doe, the site supervisor, decides to migrate to a control logics platform that can achieve RPIs as fast as 5 milliseconds. Because it's Ethernet, it can now have multiple instantaneous connections to the I/O. Right. Now the belt can travel as fast as 500 meters per second. Right. And the system can now cap as many as 200 bottles every single second. And assuming that the revenue does not change, which it normally wouldn't, the new modernized system now generates $470 every second. So modernization in this case would be a no-brainer. But what a lot of people fear is the investment cost of a full-scale modernization project. Not just the financial cost of new equipment, but the financial cost of time and the financial cost of insurance. You cannot be certain whether the new equipment will work well with each other and work within the confines of your processes. So there's an uncertainty to it. And that's where we come in and say, have you heard about stage migration? So instead of that rip everything out approach, stage migration suggests doing it in stages. It says, let's change one thing and see what happens. And that in its own carries a lot of benefits. For one, you are not paying the full upfront cost of a full-scale migration. You can now pay for what you can afford until you finally have a fully modernized solution. That means you can also test your new equipment within the confines of your processes, thereby minimizing the risk of a full-scale migration. The time that it will take you to install a small part of a modernized system is going to be much, much less than the whole thing. So you're bound to have less downtime. And the minute that you rip the first small thing out, it becomes a spare for the rest of the system. You don't need to pay the full bill when you go out for beers with your spares connection anymore. You can now split the bill 50-50. And I can go on and on about the benefits of stage migration. For a time, though, you need to have a hybrid system that has a mixture of modern and legacy equipment, which speaks the legacy language and the modern language at the same time. If we go back to our real example, first thing that you can change is your PLC. But your PLC talks Ethernet IP, which is a modern language, while your I/O talks remote I/O. And you want these two devices to interact. So we would give you a solution that sits between the two different protocols and allows for near seamless communication between the old and the new. And then you can continue to the next stage of your migration, all while using the same gateway between Ethernet IP and remote I/O, replacing the old I/O with new I/O until you finally have the entire system modernized. I probably said modernized one too many times. You think I'm trying to hypnotize people. At ProSoft, we provide solutions for a number of legacy protocols: Data Highway Plus, Remote I/O, DF1, Bluehost, S903, Texas Instruments, and many more. Get in touch with your local ProSoft guy for more information on that. Because of time, we will be taking a closer look at just DH Plus, AB Remote I/O or Allen Bradley Remote I/O, and DF1 protocols. Starting with Data Highway Plus and Remote I/O. Our ANX2 gateway, our ANX2 DH-Real gateway, is an excellent migration solution, connecting Ethernet IP devices to DH Plus and Remote I/O networks. The device can operate as a DH Plus node or Remote I/O scanner or Remote I/O adapter, which means you can now integrate upstream or downstream. So for a Remote I/O network, you can integrate upstream by replacing a legacy PLC with a later Ethernet IP controller while maintaining the existing remote I/O racks that are legacy. In this setup, the ANX2 will work as a remote I/O scanner. Alternatively, you could integrate downstream and just change the I/O racks to Ethernet compatible I/O modules. In this case, the ANX2 is working as a remote I/O adapter. And the functionality of the module is not just limited to I/O. You can also have it with HMIs. Say you want to upgrade an old remote I/O HMI to an Ethernet-capable Panel View Plus. You can have the ANX2 sitting between the HMI and the PLC, providing a path of communication and protocol conversion from one machine to the next. You could have the ANX2 doing the same function for a legacy PLC with a newly installed PowerFlex drive, for example. That's going to, and the PowerFlex drive would support Ethernet IP, of course. And with our ANX2 Real gateway, you can have multiple drives working off the same ANX2 module. In fact, you can have as many as 4 drives connecting to one PLC through a single ANX2 module. So the iterations for remote I/O migration are many. The ANX2 can handle most, if not all of them. And the same thing goes if you're talking of DH Plus or Data Highway Plus. The ANX2 can allow for direct messaging between Rockwell Ethernet IP controllers and DH Plus controllers and devices. This would allow you to have both Ethernet IP and the DH Plus controllers operating at the same time on the same equipment until you're confident enough to phase out the old DH Plus controllers. The ANX2 also allows you to configure DH Plus controllers via Ethernet using IS-Links and IS-Logix 500 and IS-Logix 5. Migration can be a complicated technical task. And having a gateway that can assist in the troubleshooting process would be invaluable. The ANX2 has a network monitoring feature on its web interface that will report the status of all the nodes that are available on the DH Plus network. The module can go further and actually sniff the DH Plus traffic to allow for an in-depth analysis on how the devices on DH Plus network are communicating with one another. For remote I/O, the unit comes with a software utility that will allow you to browse the remote racks with your PC via Ethernet, allowing you to see devices that are present and the status of said devices. That was remote I/O. Now we move on to DH Plus, to DF1 support. Our PLX51 DF1 gateway allows you to migrate from DF1 to Ethernet IP, replacing the now discontinued NetENI cards, NetENI modules from Rockwell, while giving you something that is a little bit more functionality, which is our DF1 router gateway. You can connect an Ethernet machine to a DF1 controller to upload, download configuration, go online with your controller via Ethernet. This allows you to make a DF1 controller part of the Ethernet network. You can also have direct messaging from Ethernet IP devices and your DF1 controller. Allows you to migrate downstream from DF1 to Ethernet IP and Ethernet IP capable devices. And not to forget direct messaging between PLCs and legacy DF1 controllers and the current Ethernet IP for the new PLCs, of course. The gateway also has migration support. The DF1 gateway allows you to capture and monitor serial and Ethernet datagrams from the module's configuration utility. Not only can you see the actual data being transmitted between the devices, you can also see whether the message was accepted or not, and if not, exactly why it was rejected. The whole goal is to make the migration process as easy as possible for the end user. So now to wrap things up, we have discussed modernization and the reasons for it. That brought us to stage migration, and we discussed all the benefits of taking a stage migration approach. We identified the important aspects of stage migration, and then I showed you some example architectures using ProSoft Technologies stage migration solutions for DH Plus, Remote I/O, and DF1.